Welcome. The next topic that we are going to see is the test concerning paired data. Paired data. Okay. So basically, in the previous videos, we were considering the inference concerning two means, right? And those two means were from independent samples, right? Suppose we have a dependent sample, okay, like before and after some procedure, like uh, in a IT company, aptitude test was conducted for the new joiners, and after giving a training the same aptitude was given to them. So now that we are in a need to test the before and after the training, okay, salary of a husband and wife is one such example, life of left side and right side tires of a vehicle. So these are some real time scenarios where this can be used, okay. Dependent samples from two populations are taken in a way that data can be considered as n paired observations. So here the of course the null hypothesis would be mu d, which is there is no significant difference between and before and after at some significance level alpha, okay. Now that basically what should we do? We'll have to find out the difference between the observations for each pair, and we are going to use the same suitable one mean test. Okay. So same suitable one mean test means if it is a large sample, what do we do? For large sample, we will go with Z statistic. Okay. If it is a small sample, we would go with T statistics. When we go with T statistics, of course, we need a parameter nu which is n minus 1. So in both the cases, what is the thing? There is no significant difference, which means our null hypothesis is mu d is 0. This is the most, there is no significant difference means this would be the case, okay. And alternate hypothesis would be what? So it would be either mu d is not equal to 0, or mu d is positive, or mu d is negative, okay. Accordingly, whatsoever the thing, whether it is this thing we need to consider, or this thing we need to consider, or absolute of z is bigger than z alpha upon 2 or t, okay. So correspondingly we will have to consider the thing, okay. Moving further, we have an example here. In order to determine the fat content in a milk, both the company and the vendor take sample from each lot and determine the fat content, okay. So basically with the same milk product, milk, the company is testing as well as the vendor is testing, okay. So there are 10 lots. So this clearly indicates that our n value is 10, okay. This is the company test and this is the vendor test. Now that we need to find out the difference of these two things. So when we find out the difference, it is 0.29 point minus 0.29, it is minus 0.13, 0.08, 0.35, 0.41, 0.48, and 0.03, 0.43, 0.02, and minus 0.11. These are the things, okay. Now that we need to take the sample mean, okay, x bar, for this difference, okay, it happens to be 0.127, okay. And the variance or the sorry standard deviation is 0.2719. Now that we are ready to perform the test statistics, here n value is 10, so we'll have to make use of t statistic, okay. That is what, this quantity minus 0 divided by 0.2719 divided by under root 10. So this happens to be 1.477, okay. And here what was the alpha value? We are asked to check at 0.0 5 level of significance. So T 0.025 is 2.262 for nu equals 10 minus 1, which is 9. Okay, and here absolute of T is what? Smaller than T 0.025. That is, absolute of T is not bigger than T of alpha upon 2. So we accept null hypothesis. Okay, that means there is a difference between the measurements. Okay, so therefore there is no significant difference. This is the conclusion that we make. That's it. Thank you.